Dear students, welcome to EPG Pathshala. In this module of measure of dispersion, we will discuss different measures of dispersions. Before that, we will discuss what is a requirement for doing measure of dispersion in statistics. As we already covered center tendency measures in our previous module and we discussed many measures there. But here we will see that there are some drawbacks of using different measures of center tendency. So we require measure of dispersion to overcome them. So here we will discuss absolute measures of measure of dispersion in this module, and in the next module we will discuss relative measure of dispersion. Let's get started. A complete introduction of measure of dispersion and different measure of dispersion are discussed with examples in this module. Properties of different measures are also discussed with their merits and demerits through this module. One can understand about which method to use under what type of conditions. So in this module, an important measure that is used to see how observation varies from the mean value. When one is interested to know about the variation of observations from the mean value, the measures that are used to detect this variation in the observations are called measures of dispersion. In the module center tendency measure 1 and center tendency measure 2, we discuss about different measures of center tendency. We discuss about the mathematical averages and positional averages. The basic purpose of these measures is to find out a single value that represents the whole data set. Also, concentration of observations about the center part of the data were discussed, but these measures will not take into account of the fact that whether two or more different data sets have same mean value, but it does not mean that the observations are same. For example, we have two data sets given below that have same mean value, but the observations are not same. One can easily see that data set 1 has the values 8, 9, 10 up to 15, and data set 2 that has small values also and very large values also, but the total sum of both data set are same, that is 66, and the mean is also same, that is 11. Now the question is how we can say that mean is the presentation of the data. The answer is center tendency measure gives you just an idea about the concentration of the observations around a center value, but it does not say anything about the variation of these observations from the center part. In data set 1, the values are very close to each other and also the mean value, so we can say that 11 is the correct representation of the data set. But in data set second, observations are very scattered and also very far away from the mean value. Hence, one can see that 11 as a mean value is not represent the whole data set in a correct manner. To overcome this problem, we use measures of dispersion. Some authors have defined the measures of dispersion as dispersion is the measure of variation of the item that is given by A.L. Bowley. Dispersion or spread is the degree of scatter or the variation of the variable about the center value by B.C. Brook and W.F.L. Dix. In literature, the dispersion is also considered as synonym for heterogeneous in the data, as heterogeneous is basically used to understand the extent of variation among observations. Dispersion can only be 0 if all the observations have same values. The dispersion is more when the difference between the observation is very large. So one can say that if the variation is small, like in data set 1, then it is considered as insignificant, but if the variation is large as shown from the data set 2, then it is considered as significant. Also, dispersion is termed as second order mean, as center tendency measure is the first order mean where one can see the tendency of the values around the middle of the data, as measures of dispersion are basically used to discuss about the variation, scatterness of the observations from the central tendency measure. The measure of central tendency and measures of dispersion both together discuss about the characteristics of the dataset, but they do not able to demonstrate that to what extent the observation deviate from the center value. That is, whether equal number of observations are dispersed from the center tendency or whether the data is symmetrical about the mean or not. It also gives an idea of how many observations have their values below the mean value or above the mean value. If one is interested to know about the concentration of the observation around a central tendency measure, then it is essential to study two more measures. These are skewness and kurtosis. These two measures are considered as a supportive measure for better understanding the characteristics of the data. Skewness and kurtosis is discussed in the module Measure and Dispersion second with skewness and kurtosis. Now, importance of measures of dispersion. The main motive behind using these measures to check the authenticity of the central tendency measures, it is used to see whether the values of the central tendency measures are reliable or not. The second important thing about the measures of central tendency is that they are also used to compare the two data sets through the relative values. This measure is also useful in identifying the reason behind the variation in order to control them, but they are not helpful to give the exact reason behind variation in the observations. For example, in electronic industry, quality of an item cannot be judged only by through whether an item is produced under defined limit, but also through the variation between the characteristics of observations. Measure of dispersion are also used to help for further analysis of the data like correlation, regression, testing of hypothesis and ANOVA, etc. As there are many measures of dispersion, the ideal measure prevails the following characteristics. The value of these measures should be rigid. It should be calculated on all the observations. The method should be easily calculated and understood by non-mathematical background person. The measure should be used for further algebraic treatment. The measure should not be affected by extreme values and fluctuation of the observations. The measure of dispersion are further categorized into two types. These are shown in the following flowchart. First, we have measure of dispersion that is further segmented into two parts. First one is absolute measure, second one is relative measure. Absolute measure is further categorized into different types of measures. These are range, mean deviation or quartile deviation, standard deviation. On the other hand, relative measures are categorized into coefficient of range, coefficient of mean deviation, coefficient of variation. From the figure 1, the measure of dispersion is categorized in two measures. Already discussed that we have absolute measures and relative measures. As dispersion measure is used to detect the deviation of the observations from the central tendency. If the measure of dispersion expresses the dispersion of the observation in the original units, then the measure are called absolute measure of dispersion. One can only compare the variation between two series if both series are in same unit, otherwise comparison is not meaningful. To overcome this problem, those measures that give the dispersion value in terms of ratios and percentage are called relative measures. A relative measure of dispersion is the ratio of absolute measure of dispersion with its appropriate average. These measures are independent of units and these are termed as coefficient of dispersion. One important thing while the calculation of relative measure is that the units of absolute measure and the appropriate average must be same. Now we start with the first measure of dispersion, that is range. Range is considered as the simplest absolute measure of dispersion. It is evaluated by just taking the difference between the maximum value and the minimum value in the data set. Range is equal to maximum value minus minimum value. Now we can find out the value of range for this data set, and we can see that the maximum value in the following data set is 76 and the minimum value is 23. So the range of the data set is coming out to be 53. Now we will discuss about merits of range. There are few merits of range, and these are: range is the simplest among all the absolute measure of dispersion. Range is defined in a rigid manner and easily calculated. Due to this property, it is widely used in the industry as a quality control tool. Third is, range is computed within second, hence one can get a complete picture of variability in the dataset in a short time period. Some of the demerits of range are: as range is evaluated just from the difference of maximum and minimum value of the dataset, hence it does not depend on all the observations. So it is possible that range will be same for two datasets that have same maximum and minimum value but different intermediate values that make no sense. As we already discussed that range depend on just two values and both of these values are extreme values, hence range is affected by a lot by extreme values. Also, range will not take into account the shape of the distribution. It may be possible that range will be same for the dataset whether it is symmetric or skew symmetric. Range is affected by the change in the observations. Range cannot be evaluated from the group frequency distribution with open end class. Now, quartile deviation. This measure of dispersion is related with range and it removes the drawback of range up to some extent. It is defined as the difference between third quartile and first quartile divided by 2. In other words, the formula for quartile is given here, where Q1 is the first quartile, Q3 is the third quartile. Q3 minus Q1 is also known as interquartile range. So we are interested to find out the quartile deviation for the given data set. For that, we have to arrange the observation in the ascending order. After arranging the observation in ascending order, we have to first find out the first quartile and third quartile, and quartile deviation is derived by subtracting first quartile from the third quartile and divided by 2, and the answer is coming out to be 12.5. Sum of merits of quartile deviation. Quartile deviation is easy to understand like range, as quartile deviation is based on first and third quartile, hence it removes the limitation of the range. As quartile deviation consider only first quarter and third quarter value, these values are derived by neglecting first and last 25% of the observation respectively, hence it is not affected by the extreme value. Quartile deviation is more useful to consider in case of skewed symmetrical data. Quartile deviation can be evaluated for open end class interval as it is not depend on the extreme values. Some of the demerits of quartile deviations are: quartile deviation is evaluated on just half of the observations as it neglect first and last 25% of the observations, hence it is not considered as a fully appropriate measure for detecting variation among observations. Quartile measure is based on quartiles, which are positional averages. It represents the deviation of observation among quartiles, that is just distance on scale. Quartile deviation is much influenced by the change in the observation. A change in single observation lead to change in the value of quartile deviation. Quartile deviation just give an idea about the deviation like range, so it is not the best measure for measuring dispersion. Now we will discuss third measure of dispersion, that is mean deviation. Mean deviation is computed as the absolute value of difference of observations from the center tendency, that is mean, median and mode. Mostly mean deviation is calculated by taking deviation of observations from mean and median. Let we have x1, x2, xn n observations to compute mean deviation. For that, first assume a number a and take absolute deviation of each observation from the value a, and it is given by, and take mod. So it is given by x1 minus a mod, x2 minus a mod, and so on xn minus a mod. As some of the observations are more than a and some of them are less than a, so modulus is taken to accumulate the total deviation of observations from a point capital A. Now the sum of the deviation observation from A is summation of mod of xi minus a, and the arithmetic mean of these observation will give mean deviation about mean. So the formula for mean deviation about A is 1 upon n summation over I and take mod of xi minus a. If a is chosen as mean value, then the deviation is called mean deviation about mean, and if capital A is chosen as median, then the deviation is called mean deviation about median. The above formula is used for simple series data. For ungrouped frequency distribution, the formula will be 1 upon capital N summation over I fi mod of xi minus capital A. For grouped frequency distribution, the formula will be mean deviation about A is equal to 1 upon n summation over I fi mod of mi minus a, where n is the total frequency, fi is the frequency corresponding to the ith observation, small mi be the midpoint of the class interval. So this is a question that will help you to understand how we can apply mean deviation. So calculate the mean deviation about mean for the following observations. We have observation like 30, 40, 50, 55, 60, 65, 70, 80, 90, 100. First find out the average mean of the observation. It is 64. Now take absolute deviation of each observation from 64. The values are 34, 24, 14, 9, 4, 1, 6, 16, 26. As we are taking mod, so there will be no negative value here. Take the sum of these observations and divide it by 10, because we have 10 observations, so n is here is equal to 10. The answer is coming out to be 13.4. So now if we have ungrouped frequency data, then how we can evaluate the value of mean? So first compute arithmetic mean of the data using the formula summation over fi xi upon capital N, where n is equal to summation of xi fi. The values are shown in table 2. After that subtract this mean value from each observation and take modulus. Now multiply this absolute value with the corresponding frequency. Now compute the arithmetic mean of these absolute observations. Here 8.22 is the mean deviation about mean. So from this table we have, in the first column we have observation, in the second column we have frequency, and in the third column first we have to evaluate product of fi xi and take the sum. And deviation about mean is derived at xi minus x bar, and absolute deviation about mean is derived at mod of xi minus x bar. So we are interested in to find out product of fi into mod of xi minus x bar. So derive this value for all the observations and take sum, and the sum is coming out to be 427.84 611538. And now we for finding mean deviation we required that the value should be divided by capital N. So we divide it by 10 and the answer is coming out to be 8.22. So in this example we will discuss how you can apply mean deviation about mean in group frequency data. So for that, first compute arithmetic mean of the data using the formula summation over fi mi upon n, where n is equal to summation of fi, where and m is the midpoint of the ith class interval. The values are shown in table 4. After that subtract this mean value from midpoints and take modulus. Now multiply this absolute value with the corresponding frequency. Now compute the arithmetic mean of these absolute observations. Hence the mean deviation about mean for group frequency data set is coming out to be 6.556. From table 4 we can see that we have class interval that that is given in the first column, and we have midpoints that we have derived from the values of class interval by adding the lowest value of class interval and the highest value of class interval and take their mean. So it is coming out to be, let us coming out to be, that is shown in column 2. So we have frequencies available, that is shown in the third column, and we derive the values of Fi, Mi, and deviation from mean is derived from subtracting x bar from the midpoints. Now after taking absolute deviation, the negative values are coming out to be positive, and we have to multiply Fi into Mi minus x bar and take mod of it. So after summing all the values of product of frequencies and and modulus of Mi minus x bar, the sum is coming out to be 216.36, and now we have to divide this value with capital N, and we get the result that is 6.556. Now some of the merits and demerits of mean deviation. There are some merits of mean deviation as well. These are: mean deviation is defined in a rigid manner. Mean deviation is an easy method for a non-mathematical background person. Mean deviation is based on all the observations, so it is better than range and quartile deviation measures. Mean deviation is less influenced by the extreme value than range and standard deviation. Mean deviation is appropriate for comparison purpose, but it is derived from the deviation of observation from center values, that is mean, median or mode. Mean deviation is basically an average of absolute deviation from center value. Hence it removes biasness to some extent that occurs due to observations while calculating and provide an accurate values for dispersion. There are few demerits of mean deviation as well. These are: the major drawback of mean deviation measure is that while computing it, we ignore the sign of deviation and take absolute of it. So one cannot get any information about the concentration of the observations above the mean or below the mean. So this measure is not useful for further mathematical treatment. Mean deviation cannot be computed for open-end classes distribution. Mean deviation is not an accurate measure of dispersion for highly skewed data. Although mean deviation has some limitations due to its simplicity and easy to understand feature, it has great importance in accountancy, economics, forecasting and business sector. Now we will discuss another measure, that is standard deviation, and it is the most widely used method for dispersion. Carl Pearson in 1823 first introduced this measure, and after that it is most widely used measure of dispersion till date. Standard deviation is the measure that prevails all the features that other measures lack of. So basically it is considered as an ideal measure of deviation. It is also known as square root of variance, root mean square deviation, etc., and denoted by the Greek letter sigma. Standard deviation value is high or low when there is more or less variation among observations respectively. Let us suppose we have n observation and these are x1, x2, xn, and x bar be the average value. Then the standard deviation is evaluated as square root of summation of xi minus x bar upon small n. For frequency data, the formula is square root of summation of fi xi minus x bar whole square divided by n, where fi represents the frequency and values and x bar is the mean value. For group frequency data, the formula is square root of summation over fi mi minus x bar whole square divided by capital N, where n is the total frequency, fi is the frequency corresponding to the ith observation, mi be the midpoint of the ith class interval. Now in this data set we are trying to find out the values for standard deviation. For finding out the standard deviation, first we have to find out the mean value of the observation. So as we can see that the mean of the observations is 64. So subtract each observation from 64 and take square, add the square of all the observations, and it is coming out to be 4290. Now divide this sum by 10 and take a square root. So the value for standard deviation is 20.712. As the observations are very far away from the mean value, hence the standard deviation is coming out to be very high. Now calculate the standard deviation for the following data set. Here we have ungrouped frequency data. So we are using the formulas for evaluating standard deviation in this data set. Calculate the mean of the observations as shown in table 6 and subtract the mean from the observations as shown in the fourth column. Now take square of these observations as shown in the fifth column in table 6. Column 6 shows the product of frequencies with values from column 5. Now take sum of the observations in column 5 and divide it by capital N, that is total frequency. Take square root of the values, that is 125.22, and the required standard deviation is 11.190. So from the table 5 we have in the first column we have observations and corresponding frequencies given in the second column, and first we evaluate product of Fi xi, and in the fourth column we have difference of observations from its mean value, and after taking square the values are shown in the column number 5, and after multiplying the observation with the corresponding frequencies we have observations shown in the column number 6, and we are interested in to find out the summation of all the observation, that is shown as 6511.7690. Now after that we have to divide the observation with capital N and take square root of these value. The answer is coming out to be 11.190,45716. So now we will solve standard deviation for the ungrouped frequency data. For that, first calculate the midpoint of the class interval, then calculate the mean of the observations as shown in the table number 8. Subtract the mean from the midpoints as shown in fifth column. Now take square of these observations as shown in sixth column in table 8. Column 7 shows the product of frequencies with values from column number 6. Now take sum of the observations in column 7 and divide it by capital N, that is total frequency. Take square root of the values, which is coming out to be 57.62, and the required standard deviation is 7.59. So what we have to do, we have to do the same calculation that we did in the previous question, but here the difference here is we have midpoints in place of observations here. So after doing the same calculation, we would get the values of 7.59 as a standard deviation for this particular data set, that is grouped frequency data. So there are some merits and demerits of standard deviation. These are, as standard deviation is considered as the best absolute measure of dispersion, these are the merits of standard deviation measure. Standard deviation is rigidly defined measure. Standard deviation is basically based on all the observation. Standard deviation is evaluated by squaring deviation of observation from the mean. This makes a standard deviation for further mathematical treatment. Standard deviation has less influenced by the change in the sample observation. It is also possible to compute the combined standard deviation of two or more data set from the individual standard deviation. Standard deviation is used for further statistical analysis like skewness and correlation. Although standard deviation is considered as the best absolute measure of dispersion, but it is not free from demerits. These are, standard deviation is very difficult to understand for a non-mathematical background person. Standard deviation gives more weight to extreme values and less weight to values close to mean, as while scaling the deviation this bias will be increased. Although standard deviation has some demerits or limitation, but this is the widely used method for the absolute measure of dispersion. In this module, we discuss the importance of measure of dispersion, and for that we discuss absolute measures and in which we discussed first range, then quartile range. Third one is mean deviation, about mean and other values, and at the last we discussed standard deviation. These all measures are very useful in practical life. So we discuss these methods for all types of data set. So hope you enjoyed it. Thank you.